Good day, class. This is your teacher Tin, and today we will be having a podcast for our research study. A podcast is an audio recording where we can listen to discussions on a particular topic, just like a radio show, but more focused on learning. In this podcast, we will tackle the topic of factoring polynomials, specifically focusing on two important concepts, which are the difference of two squares and the sum of two cubes. We'll break down how to identify these patterns of polynomials and how to apply the correct factoring techniques. So, get ready to listen and learn. Today, we will be discussing about the factoring of polynomials, difference of two squares, and the sum of two cubes. So at the end of the week, students are expected to define and recognize polynomials that are either first, difference of two squares, or sum of two cubes. Second, factor polynomials using the appropriate formulas for the difference of two squares and the sum of two cubes. And lastly, solve algebraic expressions using the following techniques. So, first, let's talk about what is a polynomial. A polynomial is an expression which is composed of variables, constant, and exponents that are combined using mathematical operations such as addition, subtraction, multiplication, and division. Let's proceed to the difference of two squares. For now, let us identify whether or not an expression is a difference of two squares, and second, factor the difference of two squares completely. So next, let us tell whether the following number is a perfect square or not. So let's first identify if these numbers are perfect square or not. So first number, 25. Is it a perfect square or not? Yes, it is, because if we multiply 5 times 5, it would be 25. So next, 75. It is perfect square or not? No, it is not. Third number, 81. Is it a perfect square or not? Yes, it is, because if we multiply 9 times 9, it would be 81. Next, 40. Is it a perfect square or not? No, it is not a perfect square. Next is 144. Is it a perfect square or not? Yes, it is, because if we multiply 12 times 12, the answer would be 144. Next number, 60. Is it a perfect square or not? No, 60 is not a perfect square. Next, 100. Is it a perfect square or not? Yes, it is, because if we multiply 10 times 10, the answer would be 100. Next, 64. Is it a perfect square or not? Yes, it is, because if we multiply 8 times 8, the answer would be 64. Next number, 88. Is it a perfect square or not? No, it is not a perfect square. Next is 121. Is it a perfect square or not? Yes, it is a perfect square. Why? Because if we multiply 11 times 11, the answer would be 121. Okay, next, we have perfect squares number here, and we would try to write it in exponential form. So first number is 25. What would be the exponential form? It would be 5 times 5 equals 5 squared. Since 5 times 5 is equals to 25, therefore we can rewrite it as 5 squared. Next number is 81. Since 81 is equals to 9 times 9, therefore we can write this as 9 squared. Next number is 144. Since the square root of 144 is 12, Therefore, we can rewrite it as 12 cubed. Next number is 100. Since we can rewrite, or since the square root of 100 is 10, therefore we can rewrite it as 10 squared. Next number is 64. Since 64 is 8 times 8, therefore we can rewrite it as 8 squared. Next number is 121. Since 121 is equals to 11 times 11, therefore we can rewrite it as 11 squared. So we need to know how to rewrite or find the square root of in each number or the perfect squares because we need it in difference of two squares. Then let's proceed in defining what is the difference of two squares. The difference of two squares is a method of factorizing used when an algebraic expression includes two squared terms, one subtracted from another. Example is a squared minus b squared. So when subtracting a squared term from another squared term, we can use the difference of two squares method. Square numbers are sometimes called perfect squares. An example of an expression we can factorize using the difference of two squares might be x squared minus 4 or 4x squared minus 25. To use quadratic factorization on an expression in the form a squared minus b squared, we need double brackets, which is the factorizing and the expanding brackets. Or in other words, difference of two squares is if x and y are real numbers, variables, or algebraic expressions, then x squared minus y squared. The difference of two squares is the product of sum and difference of those terms. So what is it? Let us always remember that it will be the product if we have the sum and difference. So let us explain it further. If you can see, there is x squared and y squared. And it is the product if we have x plus y times x minus y. If you can see, the other one has a positive sign and the other one has a negative sign. X squared is a product of x times x, and y squared is the product of y times y in the factorial form. So, as you can see, it is x squared minus y squared because it is the product of the positive and negative, which is the x plus y times x minus y. So how to factorize using difference of two squares? In order to factorize an algebraic expression using the difference of two squares, first, write down two brackets. Second is square root the first term and write it on the left-hand side of both brackets. Third, square root the last term and then write it on the right-hand side of the both brackets. Fourth is put a positive in the middle of the one bracket and a minus sign in the middle of the other bracket. So example, find the factor of x squared minus 4. So first, write down two brackets. Second, find the square root of the first term and write it on the left-hand side of both brackets. So, what is the square root of the first term? The first term is x squared. Therefore, the square root is x. So, write it on the left-hand side of the both brackets. So, second, square root the last term and write it on the right-hand side of both brackets. So the second term is 4 and the square root is 2. Next is put a positive sign in the middle of one bracket and a negative sign on the other one. So therefore, the factor of x squared minus 4 is x plus 2 and x minus 2. Second example, find the factors of 16m to the power of 4 minus 36. First is write down two brackets. Second, square root the first term and write it on the left-hand side of both brackets. So the first term is 16m to the power of 4. And the square root of 16m to the power of 4 is 4m to the power of 2. Third, square root the last term and write it on the right-hand side of both brackets. The second term is 36, and its square root is 6. Fourth, put a positive sign in the middle of one bracket and put a negative sign on the middle of the other one. So, the factor of 16m to the power of 4 minus 36 is 4m squared plus 6 and 4m squared minus 6. So let's have another example. The given is 9x squared minus 100. So first, write down two brackets. Second, square root the first term and write it on the left-hand side of both brackets. So the first term is 9x squared. So what is the square root of 9x squared? It would be 3x. Then the second term is 100. So what is the square root of 100? It is 10. So write it on the left side of the both brackets, the 3x. Then the third one is square root the last term, which is the 100. And we already know that the square root of 100 is 10. Therefore, write it on the right side of both brackets. The next is put a positive sign in the middle of the one bracket and the negative sign in the middle of the other one. Therefore, the answer would be 3x plus 10 times 3x minus 10. Have another example. So 4x squared minus 81. First, we write as difference of two squares. So let's write a bracket, then find the square root of the first term, which is, what is the square root of 4x squared? It is 2x. Then the square root of 81 is 9. Then second is copy the first and second term. So what is the first and second term? It is 2 and 9. So let's write it as 2x sa left bracket and 2x and 2x sa right bracket. Then also copy the second term, which is 9, sa both left and right bracket. Then let us not forget the signs, which are the minus sign and the plus sign. Then now we have a factored form, which is 2x plus 9 and 2x minus 9. It's so easy, right? Next, 81m squared minus 4n to the power of 4 and p to the power of 6. So first, we write it as difference of two squares. So let us find the square root of 2m squared, and it would be 9m. So in second term, so let us also find the square root of the second term, which is 4n to the power of 4 and p to the power of 6. So the square root of the second term is 2n squared times p cubed. So why is it 2 cubed, n to the power of 2 and p to the power of 3? It is because 2 times 2, which is the exponent outside the bracket, 2 times 2 is 4 and 2 times 3 is 6. Then next, copy the first and second term. So the first term is 9m and the second term will be 2n to the power of 2 and p to the power of 3. So you will just have to copy it from the to the left and the right bracket, but let us not also forget to put the positive and the negative sign. So we already have a factored form, which is 9m plus 2, 9m plus 2n to the power of 2 and p to the power of 3 times 9m minus 2n to the power of 2 and p to the power of 3. So next, let's proceed to the next example, which is negative 49x to the power of 8 plus 25. So it should be difference, but then the sign is positive, therefore it is not the difference of two squares. So we should write it as difference of two squares. Therefore, it would become 25 minus 49x to the power of 8. So next, let us find the square root of 25, which is 5, and the square root of 49, which is 7. Then why is it raised to the power of 4? It is because 4 times 2 is equals to 8. Then next, copy the first and second term. What is the first term? It is 5. And the second term is 7x to the power of 4. So we now have the factored form, which is the 5 plus 7x to the power of 4 times 5 minus 7x to the power of 4. And that's all for the difference of two squares. Next is, let's proceed to the sum of cubes. What is a sum of two cubes? It is a two-term expression where both terms are cubes and each term has the same sign. And it has a formula, which is a cube plus b cube equals a plus b times a squared minus ab plus b squared. The formula to find the addition in two polynomial, which is the a cube plus b cube, is known as the sum of cubes formula. Let's learn more about the sum of cubes formula with a few solved examples. This factoring formula comes in very handy when solving algebraic expressions of various types. Memorizing this formula is also easy and can be done within a matter of minutes. So it is very similar to the difference in cubes formula as well. So what is the sum of cubes formula? In this section, let us go further and understand what exactly does it mean. Let us discuss on how to factor the sum of two cubes. So, if the given is x cubed plus y cubed, it means it is a sum of two cubes. So how would we factor it using this form? Always remember that x is the first term and y is the last term. So this x plus y times x squared minus x times y plus y squared is the factored form of x cubed plus y cubed. So copy the x and y, which is the first and the last term, then squared the x, which is the first term, then minus the product of the first term and the last term, then plus the square of the last term. So if the given is x cubed plus y cubed, the factored form will be x plus y times x squared minus x times y plus y squared. So now let us identify whether or not an expression is a perfect cube and factor the sum and difference of two cubes completely. So first, tell whether the following number is a perfect cube or not. So let's talk if this number is a perfect cube or not. So first, let's start with number 8. Is it a perfect cube or not? Yes, it is a perfect cube because this is 2 times 2 equals 4 times 2, that is 8. Next, 25. Is it a perfect cube or not? No, it's not a perfect cube because it's just a perfect square. Next is 64. Is this a perfect cube? Yes, it is a perfect cube because it is a perfect cube of 4 times 4, 16, and 16 times 4 equals 64. And next, 40. Is it a perfect cube? No, it is not a perfect cube. Next number is 27. Is it a perfect cube? Yes, it is a perfect cube because if 3 is raised to 3 is equals to 9, then 9 times 3 is equals to 27. The next is 60. Is it a perfect cube? No, it is not. The next number is 125. Is it a perfect cube? Yes, it is a perfect cube because of 5 is 3. 5 times 5 is 25. Times 5 it is 125. The next number is 72. Is it a perfect cube? No, it is not. The next number is 216. Is it a perfect cube? Yes, it is a perfect cube because if 6 raised to the power of 3, it is 216. And last number, 343. Is it a perfect cube? Yes, it is a perfect cube because if 7 is raised to the power of 3, it is 343. Next, let us try to evaluate each exponential notation. If is it a perfect cube or not. So, first number 2 to the power of third or 2 to the power of 3. What is the answer of it? So it is 2 times 2 times 2 is equals to 8. Next number, 3 cube. So it is 3 times 3 times 3 is equals to 27. Next number, 4 cube. So what is the answer of 4 cube? It would be 4 times 4 times 4. It is 64. Next is 5 cube. It would be 5 times 5 times 5 is equals to 25. Therefore, 5 cube is equals to 125. Next number is 6 cube. It would become 6 times 6 times 6 is equals to 216. Therefore, 6 cube is equals to 216. Next, 7 cube. It would become 7 times 7 times 7 is equals to 343. Therefore, 7 cube is equals to 343. Let us proceed to examples. So, I have here a cube plus 64. First step is to x cube plus y cube muna siya. So, we will write this as sum of two cubes. So, we will have a raised to 3 plus 4 raised to 3. Why 4? Because we should cube the 64. So 4 times 4, 16 times 4, which is 64. That's why it is 4. Then the a is the x and the 4 is the y, which is the last term. A is the last term and 4 is the A is the first term and 4 is the last term. Then next, we will supply the missing term. So it is our factored form is x plus y times x squared minus xy plus y squared. So So we will supply the missing terms, which is x is a, then y is 4, then the second bracket is a squared, which x is a, so it would become a squared, then in the middle part, which is the xy, it should be a times 4, then the last part is y squared, then it would become 4 squared. Therefore, the factored form will be a plus 4 times a squared minus 4 times a, or 4a plus 4 squared. Next, 8b cubed plus 27c cubed. So first, let us rewrite a sum of two cubes. So what is the number that if we multiply itself by 3, we will have the product of 8. So it is 2. Then b. So the first term will become 2b cubed. Then next is the 27. We should find the number that if we multiply itself by 3 or 3 times, it will become 27. So it is 3c or 3. Then it will become 3c cubed. Then in the answer, 2b is the x or the first term, and 3c is the last term. The next, let us supply the missing terms. Then following the x plus y times x squared minus xy plus y cubed, y squared. Then x is 2b plus y is 3c. Then x squared, what is the x? So 2b. Then minus x is 2b, y is 3c, plus y is 3c. Then we now have the factored form of 2b plus 3c times 4b squared times 6bc plus 9c. The middle part, which is the 6bc, it became 6bc because we multiplied the 2b times 3c. Then the first term is 4b squared. Why it become 2b squared? Because it is 2b squared. So 2b squared is equals to 4b. Then the 3c squared is equals to 9c. Use the sum of cubes formula to find the factor of 216x cubed plus 64. To find factor of 216x cubed plus 64 using the sum of cubes formula. So first, 216x cubed plus 64 is equals to 6x cubed plus 4 cubed. Using the sum of cubes formula, which is a cubed plus b cubed is equals to a plus b times a squared minus ab plus b squared. Let's now put the values and start factoring it using the techniques. So first, 6x cubed plus 4 cubed is equals to 6x plus 4 times 6x squared minus 6x times 4 plus 4 squared. Next, it will become 6x cubed plus 4 cubed is equals to 6x plus 4 times 36x squared minus 24x plus 16. And next, it will become 6x cubed plus 4 cubed is equals to 8 times 3x plus 2 times 9x squared minus 6x plus 4. And the answer would be, therefore, the factor of 216x cubed plus 64 is 2, 3x plus 2, and 9x squared minus 6x plus 4. Second example is factor x cubed plus 27. So first, let's copy the formula, which is the a cubed plus b cubed is equals to a plus b times a squared minus ab plus b squared. Next is, it will become x cubed plus 27 is equals to x cubed plus 3 cubed. Next, it will become x plus 3 times x squared minus x times 3 plus 3 squared. Therefore, the factor of x cubed plus 27 is x plus 3 and x squared minus 3x plus 9. That would be all for factoring polynomials, difference of two squares, and sum of two cubes. I hope you enjoy listening and learn something from it, class. Thank you.